Hello viewers, and welcome to 2 ways of solving the same algebra puzzle, part 1. I'm always on the lookout for questions that are genuinely interesting. What often makes them interesting is if there's more than one way to solve it. That's exactly what we are doing in this 2-part series. Before we dive in, I want to mention how much I enjoy the books by Chris McMullen. They're filled with clever, unusual questions, and best of all, they include full, detailed solutions. As you can see, I've collected quite a few of them. I've even bought some as gifts for a relative who's at university. Many times when I've done these questions, I'm happy with my solution. I check his solution, and his solution is far more elegant than mine. I was recently working through this particular book, and for the first time ever, it's never happened before, I did a question, and believe it or not, I preferred, that's the solution. For the first time ever, I preferred my solution to his. And that's why we're going to tackle this today. Part 1 is his solution, and part 2 is my solution. This is the actual question. I rewrote it. Find positive solutions for x, y, and z in this system of equations. And I just penciled in 1, 2, and 3. So when you refer to equations, we know which ones. And now we're going to start doing it the method that's in his book. So let us tackle the question now. I rewrote the 3 equations here. And as you remember, I called them equations 1, 2, and 3. And what I'm going to do now is substitute equation 1 into 2 and 3. So wherever we see an x, we're going to replace it with y and z, or y and z, depending where you go to school. So here I rewrote equations 2 and 3, except where there was an x, we wrote y, z. And you'll notice my z or z's, whatever you call it, I do a cursive, not a regular z. I mean, there's no rules. I myself prefer to do it because if I write z like that, it can easily get confused with the number 2 when I'm doing the algebra further on. So that's my personal taste to do the cursive z. And so there I've rewritten it after substituting in. And what I'm going to do, here's 2 equations. I'm going to multiply each side. Here, left equals right, left equals right. Therefore, left times left equals right times right. So left times left is yz, and right times right is, here's all the terms multiplied out. There's the one bracket, there's the other bracket, and there's the yz. And now we're just multiplying out each term in the brackets, like yz times yz is y squared z squared, or y squared z times minus 1 is minus yz, and 1 times minus 1 is minus 1. These 2 terms cancel out, and now we're left with yz equals yz times y squared z squared minus 1, all in a bracket. We divide through by y squared by yz, and now we get that each side is divided by yz, and we're left with 1 equals y squared z squared minus 1. We've got 1 on each side, and what we're going to do, there's 1 and there's a minus 1. If I add on 1 to each side, the left side becomes 2 equals y squared z squared. I root each side, yz equals root 2. I isolate that y, I'm dividing each side by root 2, and so y equals root 2 over z. Okay. This equation here is simply the equation we did a bit earlier over here. Remember that? And I happen to call it 2b. I could have called it anything. I happen to rewrite it over here. So that's just rewriting something from before. And remember over here, a minute ago, I said y equals root 2 over z. I plug that into this equation, that wherever I see a y, I replace it with root 2 over z. I'm plugging y equals root 2 over z into this equation. So these 2 equations are almost the same, except wherever I had a y is now root 2 over z. And now what we're doing is simplifying. If And what I noticed, these two z's can cancel out. This is like divided by z times z. So this little bit here can just be rewritten as root 2, which I have over here. So z is equal to root 2 minus 1 times root 2 over z, which is over here. And what I did was I multiplied in that root 2. Root 2 times root 2 is 2. And minus 1 times root 2 is minus root 2. So as z equals 2 minus root 2 divided by z, we times each side by z. So z squared equals 2 minus root 2. And we can root each side, like the root of z squared is z. And z would be the root of that, which is the root of 2 minus the root of 2 inside the root sign. And if I plug that into a calculator, to the first 5 digits, it's 0.765307. And that's correct to those decimal points. And of course, both are arguably correct, just depending what format we have. So there's a value for z. And now that we've got a value for y, remember back here, we said y equals root 2 divided by z. We can plug that value over here, where we, instead of that z, we can replace it with what you solved for z over there. And again, arguably this is an answer for y, or we can plug into a calculator and we get 1.84716. And all we have to do now is solve for x. Now remember equation 1 at the very start of the question. Remember at the very beginning we said x is equal to y to z. I can simply take the y and z that we already have and plug into that equation. And this here is the y that we solved for, and that's the z that we solved for a bit earlier. And if we simplify, there's a value for x to 5 decimal points. That's 1.41421. And that is the solution. That's the x, the y, and the z on the solution base of the book. Please stand by for part 2, which is my solution. And of course, there will be a link for this in the description. Thank you.